So I hated this kind of assignments when I was young, and now they are one of my favorite ones. I'm not going to draw you pictures here because pictures will add to a confusion, because actual wave looks like drawing of a particle in time. So it adds to confusion. Doesn't matter. So let us solve this assignment. A transversal sinusoidal wave. Why did I place cosine here if the wave is sinusoidal? Well, because their look is the same. You could write here a sine of this. You will get very similar. You will get correct answer, and if you write this wave as a cosine, you will also get the correct result. So you could choose. Some things will change depending on that, but both are correct. Okay, a transversal sinusoidal wave on a string has a period of 25 seconds. Period is large phi, and travel in the negative direction with a speed of 30 meters per second. Okay, at time t is equal 0. Particle on the string at x is equal 0 has a transverse position of 2 centimeters and is moving downward with a speed of 2 meters per second. Under A, find amplitude, B, initial phase angle, C, maximum speed of particle, and wave function of the wave. So first of all, this is the general expression for the wave function, for any kind of waves. So let us speak. And we need to find this phi. This is the phase angle. This is the angular frequency. This is the time. This is x dot. This is not displacement. This is something else. Doesn't matter. K. Where is K? Okay, we will calculate everything here. Doesn't matter. First thing first. Find an amplitude. What is amplitude here? Amplitude is this. Amplitude is maximum elongation. So maximum number for y is A. Why is that? Because cosine can be from -1 to +1. So this is larger value for this is 1, and at that specific moment this y is equal to the A. Okay, so at the start we have this equation. At x equals 0, this whole part here is 0, and this part is 0 also. At that time y is 0.02 meter, and that is equal a cosine of phi. Again, because t is 0 and x is 0. Transverse position, that is, this is 2 centimeters, is equal a cosine of phi. This is first equation. Second equation, we have speed. Speed is this derived with respect of time. As you can see, derivation of cosine of omega t is omega sine omega t, but minus, of course. So derivation of this in respect to t is this. And at this same instance, speed is 2 meters per second. So this is 2 meters per second, but in negative direction. That is minus 2 meters per second is equal minus omega a sine of phi. Okay, and we have this in the assignment. So this is the period, 0.025 seconds, and from there angular frequency is 251.2 rad per second. So what is this? What is this? This is this. As you can see, 2 meters per second, 2 meters per second. Omega angular frequency, which is calculated, minus this, okay. A is something that we do not know, that is amplitude, and sine of phi. And this phi is initial angle, how do you call that? Initial phase angle. So this is amplitude, this is initial phase angle. So we derive this from the speed. And we have, this is actually the same equation. This equation is same as this. And second equation is this first one. So we did achieve to have two equations with two unknown magnitudes. Initial phase angle and the amplitude. Amplitude will be in meters, phase angle will be in radians. So from this equation, we need to calculate phi, you need to calculate A, initial phase angle T phi, and amplitude is A. From there, you can do it yourself, or for complete written answer, please follow the link in the description. If you want more of this, please subscribe and tell your friends. Thank you. Bye.